All right. Quick review first. What if there was no friction? What if it could just, what if instead of rolling without slipping, so when to roll without slipping, we have to assume that friction is so strong that it can't move unless it turns itself over to kind of crawl or roll down the incline. What if there was no friction? If it did not roll and we had mu equals 0. Sure. It slides like a block. Okay, perfect. Your rest and time off did you well. It becomes the sliding block or object. If there's no friction, it doesn't matter what shape it is. What would the answer be? Since you're AP students, you can just blurt it out. Uh-oh. It becomes the sliding block problem. Anybody still need to write the stuff I have? Oh, you're so fast. You got it. Okay. Yeah? Okay. It becomes the sliding block where, I understand if you're not awake, your final energy, you use kinetic and potential energy. Your potential is mgh, because you have mass m and height h, and of course g, here on planet Earth. And then you have 1 half mv squared. So the m's cancel, and you just get 2gh under the square root sign. That's your final velocity due to energy concerns, right? And that's a multiple choice question for you at this point, right? Something slides or falls, 2 mgh. That's it. Like gravity, change of potential energy, super fast. You would resort to kinematics and equations of motion if it's a projectile. What's the component here? Where's the minimum velocity? How much time does it take? Okay, but if they just want the final velocity, oh, like we do here, right? Calculate the final velocity. That's all we're asking. Rotation is almost as fast. They have to give you a kind of a leg up. Sure. Okay. Okay. Watch out. Yes. You're going to set mgh, initial potential energy, equal to both the rotational and linear components of the kinetic energy. So to roll without slipping means, and we have some practice problems for you to think carefully about this the next couple days. To roll without slipping means I can't have any velocity down the incline unless I'm also rotating. Remember, we had angular velocity, v over r. If it has some weird halfway friction, that's the hard free response problems that you'll get. I think not even on the first test, but maybe if we do like a wrap-up test or we review next semester, the hard problems is where you slip some, and so you have an angular velocity, but it's not the same as your linear velocity. Okay, my head wants to explode. Not for the first day back. Okay, today we're rolling without slipping. So we must have a rotation, um, an angular velocity that's equal to the linear velocity. It can't slip, so it can't be any different, and we just do v over r. Okay, so we have rotational component, 1 half I w squared. Okay, we show that that is just the sum of all the linear kinetic energies of all the pieces of the disk, in this case, going around in a circle. We showed that last time. There's videos of it. Anybody questioning that? Okay, and that seems to take a while to sink in, but that's okay. And then I do 1 half the total m times linear velocity squared. Okay? So, oh man, is it just mv squared equals mgh? And so I get square root of 2g all that good stuff. Oh, be careful. For a disc. So you went awful fast back there, Ben. Thank you. Kind of lost me, but it's not a hoop. It's all like all the mass is not concentrated at r. So it has a coefficient here, 1/2 mr squared. If you have an empty wheel and nothing's inside, then it would just be mr squared. Or if we had a point mass, it's just mr squared. But if you sum all those mr squareds over a disk, that's a massive integral that we're not going to do today. We could do it. We might. I've never. The sphere one takes so long, they can't possibly ask you to do it and show that. But the disk is kind of fast, so I think we should maybe do the disk together someday. So what you need to do, especially if this is a free response question, is substitute. I have 1/2 times a half again, mr squared, that's I, and then my w squared is v squared over r squared. See what I did there? Maybe I should move my thing. Yeah. Let's like put that up there as like a hint. Okay, and then I have 1/2 mv squared. I could have substituted backwards angular velocity. If I wanted the angular speed, I could do this v is w squared times r squared is v squared. But I'm asking for the final linear velocity. So let's make this substitution and do it in mgh. Okay, you could probably substitute a little, simplify a little more than that. Oh look, the r squareds cancel. So 1/4 mv squared plus 1/2 mv squared is 3/4. And this is where I would, at this point, I'd turn on the jets with the math skills. Okay, and say v squared equals, haha, in AP you can get away with this. Okay, it's going to be gh, 2gh. Ooh, I would leave it actually 4/3. That's okay. Or you could say 2 times gh over 3. And you're probably like, wait a minute. So I would say that because 4/3, because compare it to slipping, right? Is this faster or slower? Whoops, don't need the squared there anymore. Is this faster or slower than just sliding with no friction? Okay, it's always going to be slower. You had to spend some of your potential energy to rotate the thing because it can't roll without slipping, right? That was the problem. So you have to spend some energy to rotate it as well. So it's always going to end up going slower because it has to rotate. Okay. My follow-up questions are always, what about a hoop where I is just plain mr squared? Would it be more or less, and can you do the fractions in your head? What about a sphere? Hoop, disk, and sphere is what we would always experiment on. Sphere is 2/5. But you get the idea. You can just, whatever fraction they tell you, whatever I was, it didn't have to be 1/2 mr squared. That's the coincidence of a disk. And I did the disk on purpose because that's what your homework problem's about. What if it's a hoop or if it's a sphere? Should it be slower or faster? Should we try it in real experiments? So the hoop, instead of a 1/2 mr squared, it's just mr squared. So there you actually would get a half plus a half is 1, and you get just gh, not 4/3 or 2 over square root of 3. Okay. Can you see that? Square root of gh. With a sphere, oh, I get 1/5, a half times 2 over 5 up in that term. And I have to add 5, 1/5 to 1/2, which is why I like this one. It ends up being like 10 over 7, I'm pretty sure. GH, all in the square root. Are you freaking out at me? You can't leave numbers in the denominator in the radical, blah, 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 blah. they shake a stick at you in math class and say you can't divide by radicals? Do you know why you can't divide by radicals? Oh, some people are frowning at me. Some people are just bored. Okay, because you know your calculator, it just does long division, the same procedure you learned in 3rd or 4th grade or whatever. When you divide a number by number in a calculator, it just lines up the digits and it modifies them just like you did. Digit by digit by digit and goes. How many digits does the square root of 3 have? It's an irrational number. It has infinitely many. So the reason in math class that they don't want you to divide by an irrational number is because it has infinite digits and you can't actually compute the problem, right? But you can punch that in your calculator because it does what we do in physics. It rounds to a certain number of digits. It's a lot in your calculator, like 10, but it just rounds. How many digits do we ever want in physics? Like 3, maybe 4. So it's fine, right? I can certainly find the square root of 3 to 3 or 4 significant digits and just use it anyway, right? And that's absolutely what you should do on an AP Physics test. They only ever want 3 sig figs max. Okay, so just use it to whatever accuracy you need. Don't worry about this. This is totally fine on a physics test. Okay? Because we acknowledge we never use all the digits anyway. Okay? So kinetic energy, your homeworks I'm not quite done checking, but they look good. At least you were able to use kinetic energy fall with the rod falling and the thing falling. Okay, it's not that bad. So the first problem kind of hits you when you see the homework like a smack in the face. Oh no, what do I do about this? You should probably just use change in energy. And just consider that first. There's a second problem that actually talks about the torque, and so I expect to have to help with that one. But I want you to kind of try it today. Okay. Any questions? So you can kind of fly through that. It's not quite worth memorizing. The results here, it's worth memorizing the procedure. You're going to have to do change in potential energy equals both kinetic terms. But there you go. If they ask multiple choice, they're going to have to help you with it.